All right, ladies and gentlemen, welcome back. We're here talking about section 8.2, testing the difference between the means. All right, so instead of performing a z-test, we will be performing a t-test here between the two population means because they are small independent samples. All right, and we'll talk about that some more here in the notes. Let's move on. Now, make sure you get this in your notes somewhere. They are the same big note pieces that are in your book. All right, we do have some differences here in our formula pieces. Note that we're dealing with T and not Z like we were in the previous slide. Let me go with a nice blue here. Oh, I'm sorry, we went forward one slide too far. Notice we're talking about T instead of Z here. Also, there are some additional things we have to worry about. If the variances are equal, all right, we can use these formulas here. If the variances are not equal, we have to use this formula down here. Okay? Somewhat different. Okay, and we will get into that more later, or you will at least see that later in some of your examples. So, here's a flow chart. I would definitely suggest you pause this and copy this down, okay? Because you need to be working through these questions to determine if you can do a test or which test should you do. All right, so are both sample sizes at least 30? If the answer is yes, then you need to use the z-test, which we've already gone over. All right, if the answer is no, you need to ask yourself, are both populations normal? If they are not, you cannot do either z-test or t-test. Okay? If both populations are normal, are both population standard deviations known? All right? If they are known, you can go ahead and use the z-test. If they are not known, you need to ask yourself, are the population variances equal? All right? If they are equal, you can use the t-test with this formula, all right, that we talked about over here in this standard definition piece. If they are not equivalent, then we are going to use the second formula we talked about in this definitions piece. Okay? So just make sure you're somewhat familiar with those because we will be using them here in 8.2. Okay? Here is our notes once again for the steps. And like I said, it's pretty familiar. The only thing that really is different is because we're dealing with a t-test this time, we are obviously going to be calculating the degrees of freedom. And obviously we are not using table 4, the Z table. We are using table 5, the T table. Okay? Other than that, most of this is pretty much the same. Once you figured out what test you're supposed to do, just run the test. Okay? So the results of a state mathematics test for random samples of students taught by 2 different teachers at the same school are shown to the left. Can you conclude that there is a difference in the mean mathematics test scores for the students of the 2 teachers? Use a level of significance of 10%. Assume the populations are normally distributed and the population variances are not equal. All right, so right there they gave us 2 humongous pieces of information that we will definitely put to good use. All right, so let's go ahead and start off with our hypothesis. What is our null? What is our alternate? Okay, now we would assume that 2 teachers teaching at the same school, they would have pretty much the same average across the population of their students. Obviously, the alternate should be, well, the teachers are different. That does not necessarily mean that the means of their students' state test are going to be the same. Okay? So we're going to work forward from there. Let's go ahead and calculate alpha. They told us that it's 10%. And our degrees of freedom. All right, our degrees of freedom. Well, how many people, how many students are in our sample? Now, it's really key here that we use the lowest number, okay? Because we don't want a higher degree of freedom than necessary, all right? So since 8 is the lower number, we're going to use that. 8 minus 1, our degrees of freedom equal 7, okay? Now, go over to your t-table, and I don't have a t-table up here on the presentation, but you guys do know how to use the t-table. You've done it before. All right, so if we plug in our degrees of freedom and our alpha value, we should find, and remember this is a two-tailed test, all right, we should find that our negative boundary is negative 1.895 and our positive boundary is 1.895. Okay? Now let's buzz on over here and let's calculate our standard deviation of x bar 1 minus x bar 2. Okay, and remember, going back here to our, if I can get this to work correctly, remember going back here, since the variances are not equal, we're definitely going with this formula piece right here. Okay, so just be aware of that. And notice here's the note about using these smaller degrees of freedom, which we have already started. Okay? So our formula is going to be, and remember, I would like you to write it out just so you become more familiar with it, standard deviation of the first teacher's student population squared plus the standard deviation of the second teacher's population squared. And when we plug in all those values, we get 39.7 squared divided by 8 plus 24.5 squared divided by 18. All right, and that equals approximately 15.1776. All right, so we come down here into our t-test. And of course we have x bar sub 1 minus x bar sub 2, all minus the mu for the first set minus the mu for the second set. And we of course divide that by the standard deviation of x bar sub 1 minus x bar sub 2. Go ahead and plug in our values here. We should get 473 minus 459. Put that in parentheses. Now, remember, we're assuming that the mu's, or the means of the population, are equivalent, so that value should be 0. And the value we found above for our standard deviation is 1.776. So, this value should be approximately equal to 0.922. Now, let's go ahead and look at our t-test. Right there's our two tails, negative 1.895 and positive 1.895. All right. And obviously 0.92 falls right in here, so this is an obvious fail to reject. And if we were going to spell out our answer in a sentence, we would say there is not enough evidence at the 10% level of significance to assume, or I'm sorry, to conclude that there is a difference in the mean mathematics test scores for students of these two teachers. All right, guys. So hopefully you can use this in your pursuits of solving problems in 8.2. And remember, we are not going to do any assessments on this until I get back, and we definitely go over some more problems. Okay, so don't feel like, oh my goodness, he's going to come back and we're going to get a quiz right away. It's not going to happen. All right, we're definitely going to go over this some more, massage out some of the kinks, and then we'll talk about assessment. Okay, so keep plugging away, keep doing your best, and I will see you soon.